Okay, in this second lesson for this chapter, what we're going to be looking at is square root functions. So instead of taking a square root equation and changing it, what we're going to be doing now is we're going to be looking at an existing function that's not a square root. So that would be like this red line on here is y equals x. And then what we're going to do is take that function and do the square root of whatever it is to get the new graph. So the first thing that you want to be careful of is in the last topic we were taking a square root graph and doing a transformation. We're taking that graph going up, down, left, right, stretching it, reflecting it, and so on. But now what we're doing is we're just taking some regular function of whatever it is and then doing the square root of that function, not starting with the original square root. So in terms of the graph, what we're going to be doing is we're basically going to be square rooting the y coordinate. If we're just square rooting f of x, that's basically the same as y. So you can see here on this graph, the 0, 0, we would basically take that coordinate and we'd square root the y coordinate, so square root of 0, which is still 0, so that's why it's an invariant point. If we look at this next one, it's 1, 1. We would do the square root of that function, so the square root of the y value is 1, which is also 1, so it stays the same. But if we pick a different point, like let's look up here, this one's at 4, 4. So we'd have 4 square root 4, which is 4, 2. So we can see that that point up there is now moved to 4, 2. So you get the idea. All we're basically doing is square rooting the y value. So because the square root of 0 is 0 and the square root of 1 is 1, we're always going to get invariant points when y is 0 or 1. Not the x coordinate, remember, it's just the y coordinate. So our coordinates will end up being whatever the x value is originally, they'll stay the same, but the y value will stay at 0 and at 1. And also, since we can't take the root of a negative value, we will basically never get a negative portion of the graph, so the range will always be greater than 0. So let's summarize all of that so far. So our root graph will never be below the x-axis because y has to be greater than or equal to 0. And we get invariance at whatever our x-coordinate is in 1 and whatever our x-coordinate is in 0. So those will always be at that point. And then what we see is anytime our y value is between 0 and 1, so that would be, let's suppose we had something like 1 and a half, when we do the square root of a half, we actually get a number smaller than a half, or smaller than 1, sorry. So if we do that on our calculator, we get about 0.7. And if we do another one, let's suppose we had like 1 1/4, the square root of a quarter is actually a half. So that means any value that's between 0 and 1, our y value actually ends up being taller than the original graph. And then because if you go back here, 0.7 is bigger than a half, 0.5 is bigger than a quarter, so we're always going to be above it. So if we go back to our title page, we can actually see that's the case. You can see this little section of the blue curve is actually taller than the original, only between 0 and 1. And then any value less or bigger than 1, it's always going to be smaller. So if you had a coordinate like 2, 5, the square root of 5 is 2 point something, so it's always going to be less than 5. 2, 9, we get 2, 3. So it's always going to be less. And that's about it. So to graph these things, what you want to do is just take that original line, so 4x minus 3, so let's graph that one. So if you put that in on your calculator, or if you try graphing it by hand, we'd end up getting a straight line, something like that. So now when we want to draw our square root function, remember the bottom part of the graph doesn't exist. Our 1 coordinate, let me fix my line a little bit. So our line was something sort of like that. So our 1 coordinate, our invariant points will be at the 0, so right about there. And our 1 will also be an invariant point, so we know our 2 invariant points. We know we're going to have nothing negative. We know that we're going to be a little bit above the curve like that. So then all we have to do is figure out the rest. So the easiest thing to do is just pick a couple other coordinates and do the square roots of them. So I always use 4, because square root of 4 is 2. So that means that coordinate that's at y equals 4 is going to drop down to y equals 2. And if we wanted to, we could pick 9, because square root of 9 is going to be 3. So it's going to be, somewhere in there. So then all you have to do is connect your dots, and we've got our square root graph drawn. So let's try another one. This one is a quadratic graph. So if we graph our original, the x squared, we would get a coordinate or an intersection point at -2 and one at +3. So we're going to get our graph will look some sort of quadratic, kind of like that. So now when we draw our square root, our invariant points stay the same again. Your 1s will also be invariant points, so we know we're going to curve above those two lines. And then just do a couple of the other ones. So pick your 4, square root that, that'll be at 2. So if we do that for both of them, try the 9, that'll drop down to 3, and so on. So we get the idea of what our square root function is going to look like. So let's look at one other one, slightly different, before I move on. So let's do the equation y equals square root of -x squared plus 4. So if we graph the original, it's going to be an upside down quadratic, something like that. So now when we do our invariant points, we'll be at our 2x coordinates, so we get 2 of them there, and our 1s, so that'll be there. And then the only other one we want to be careful of in this case is because it's upside down, this one here that was at a coordinate of 4 is going to move down to 2, because we have a square root of 4 is 2. Our graph ends up just being a little bubble shape kind of thing like that. And then be careful, like questions you'll get will ask for domain and range. So in this case, our original domain and range was XER for our domain, and our range would be y is less than or equal to 4. And then now for our square root graph, you can see where our x is no longer any real number, it's going only between -2 and 2. And you can see our y is going between 0 and +2. So just be careful with domain and range, make sure you have your new graph drawn, and you should be good. Okay, so here's one more. We have some sort of graph, we don't know what the equation is, but it really doesn't matter. Have your original graph, now we just want to draw our square root graph, so our 0 will stay the same, our 1 will stay the same. Let's go from 4 down to 2, and let's even go, well, 9 is off the screen, so we won't bother, so a little bit above there, and like that. And once again, we can do our domain of this new one will be x is less than or equal to 3, and our range is y is greater than or equal to 0. And our original would have been just XER, YER for the straight line. And that's all for today.